Number 2 on day 1. Okay, let me get my, oh, 4. Oh yeah, that's right. Thing. I think I heard the ding for my other thing, so let me go grab it. 2 shakes of a lion's tail, and then we'll look at this problem. Did yours get warm enough? Okay, let me go open the thing. We got this, Gavin, don't worry. We've got the meats. 'Cause we're Arby's. Isn't that right, Mia? Excuse me. All right, midterm, day 1, problem number 4. We've got a picture. It looks more or less like this. We've got A and D, and this one over here is B. This one is C. And for 4 it says measure of A, B, D equals 3x minus 200, and the measure of angle DBC equals 2x plus 300, and the measure of ABC equals 4x plus 150. So, I label this as 1 so we can talk about it, and this is 2 so we can talk about it. Where is ABD? Is it 1 or 2 or something else? It's 1, great. So, okay. Where is DBC? And where is ABC? What? Just 2? Yeah, it's both of them, right? It's the big one. So this big one is 4x plus 150. So how are all those angles related to each other? 1, 2, and the big one. Mm-hmm. 1 and 2 added up equals the big one. That's true. So that's the formula we can write. All right. So now what do we do to solve that? 3x, 4x, the negative 200, and the 150. What is 3x plus 4x? 7x. And negative 200 plus 150 is? One of them's negative, one's positive, right? So you got to subtract. Keep the sign of the bigger one. What's 200 minus 150? 50. And it's negative 50 because 200 is bigger. What do we do now? Subtract what? What? We wouldn't subtract the 50. What would we do? Subtract what? 4x. Sounds great. Now what? Add 50. Now what? You would divide by 3. Trying to decide whether I made a mistake now or if I made a mistake at a key. 3x plus, oh, I made a mistake now. This is supposed to be 2x, which would make this 5x, and this x, which would make this x. No. Did I make a mistake again? 3x, 2x, 5x, 4x, negative 200. What did I copy down? Oh, I wrote this one wrong. What am I doing? This is DBC, 2x plus 300. So when we combine like terms, this is 100. This is 5x. When we add 100 to both sides, it's positive 100. We subtract 100. This is 50. Sorry, y'all. I went crazy. Anything else from the tests? What? Number 5 says to find the midpoint between a couple points. So what is the midpoint formula? I can't hear a word you're saying. Speak up, son. What is the formula for the midpoint? average of the x's and the average of the y's. And the points are 5, 7, and -3, -2. So what are we going to put right here? What about this one?
-3.
Yes. What about this one?
7 and
-2. What's 5 plus -3?
2.
And what's 7 plus -2?
5.
Does either one of those reduce? What is 2 over 2? All right, let's look at today's stuff. What numbers did we do? Okay. Number 10 is 3. Number 12 is 128 degrees. Number 14, A, PS is congruent to QR, and PQ is congruent to SR. And 14B, something like P and Q and S and R. 16, X is 79, Y is 101. 18, I marked out A, so whatever's in the key is probably wrong, but I didn't replace it with anything. What is 18A going to be? Going to be 2, 14, 7, I think. Does that sound right? Anybody get 7? 18B is 3. 20Z is 2. And Y is 5. 22 is 0, 1.5. 24 is a proof. Their version gets 4 steps. What number did you say we went through? 28. 26. I think is the rest proofs, right? Yeah, the rest are proofs. So we can look at whatever ones of those we want to take care of. So before we do the proofs, is there anything else we need to look at? Okay. It says it's a parallelogram up in the instructions. So we're supposed to find the variables, or supposed to find the value of A and the value of B. What fact can we use about parallelograms to let us do that? Opposite sides are congruent. That's true. So, what equation can we write? Yes. Anything else? What? All right. On this one, what can we do? Subtract the 3a is fine. What's a minus 3a? Mm-hmm. Now what? What's 1 minus 15? Mm-hmm. And then what? No, you're right. Divide is right. Mm-hmm. So what does A equal? Mm-hmm. Yep. What about over here? What's 3b minus b? Mm-hmm. Now what? Subtract the 5. And what's 11 minus 5? And then we divide by 2, and we get b equals 3. Any other questions before we look at one or more of those proofs? All right, which proof do we want to start with? "24. Oh yeah, the one with all the triangles. Luckily, we've got all kinds of information about triangles, all kinds of theorems. Got all kinds of tools in our tool belt. That's not right. What am I trying to be parallel to? That's closer. Okay. A, B, C, D, G, H. We are given that BDHA is a parallelogram which is great because we've got all kinds of theorems about parallelograms too. Given that CA is congruent to CG, which we'll label in a second. And, oh, I thought there was one more thing. We're supposed to prove that angle BDH is congruent to angle G. Okay? So let's label all the things, right? So we're trying to prove BDH, so this one is congruent to this one, right? That's what we're trying to prove. We are given that CA, so this big one, is congruent to CG. So that one. So it's an isosceles on its side, right? So this angle and that angle. We've got a parallelogram. We're told that. We haven't done anything with it, but we're told that. We're also told that those are the same. What could we say? Let me pause for a quick second and ask a different question just to give us some mental tools, right? We have two shapes involved, right? This shape, this shape. This one is a parallelogram. This one is a triangle, isosceles triangle. We know it's isosceles because these two are the same. We need to say it's an isosceles, but we can do that easy, right? What do we know about isosceles triangles? Two sides are congruent, true. What else? That's the definition, right? The two sides are congruent. What else do we know about isosceles triangles? Which two? Yeah, the bottom ones. Yeah, the base ones. Base angles of isosceles are congruent. So we know that, right? So this is turned on its side. So which angles are congruent because of that? G and A, true enough. So we can probably use that in a minute. Now, this is a parallelogram. What all do we know about a parallelogram? Two important things. Well, really only one for this problem, but let's go ahead and think through all the couple of important things. What do we know about a parallelogram? Opposite angles are congruent. So this one is congruent to this one, and this one is congruent to this one. Right? So in our picture, what does that tell us? Which angles are congruent? Because that thing in the middle is a parallelogram. So A is congruent. Now remember, we have to say it's HDB, right, or BDH, because it's got more things. But yes, this one is congruent to that one. And oh, you said H. Is that what you said? Yeah, so and we have the same thing. We've got a name. We can't just call this H. We can't just call this B, because there's two angles at H and two angles at B. So AHD is congruent to ABD, right? So we've got all of those things. What else? We're not going to use it in this proof, but what else do we know about a parallelogram? We already said it earlier when we were solving 18. No, not angles, but you meant sides, right? Yeah, sides are congruent, right? True enough. We don't care about sides necessarily on this one, right? Okay, so Now that we've thought through our puzzle pieces and we've thought through what might be useful, we just need to write it down in a proof. So what could we write down? G is congruent to A. We need to say one thing first, because all we know is, all we have said so far is that this side is congruent to that side. So what is that? What kind of triangle does that make this one? Isosceles. So we need to say that, and then we can say that, right? So we can say that triangle ACG is isosceles. Because why? Well, let's just say that. Definition, yeah. I gave it that to us earlier. Definition of isosceles. Great. Then we can say angle A is congruent to angle G. Angle A is congruent to angle G because base angles of isosceles, right? Easy peasy. Great. What else can we say? We used this, but we didn't use this, right? C and H. C isn't in the parallelogram. Which ones? So this is the parallelogram, right? Let me grab a color. Let's use green. Why not? Whoa. This can be useful. You may want to get out your colored pencils when you're doing proofs. May help you see what the heck is happening, right? There's the parallelogram, right? Opposite angles. Which ones are ones that we're interested in? We just said from this that this is congruent to this, right? So, and we already know, and we're looking for this one and this one, right? That's what we're trying to prove. So what can we say with the parallelogram as far as opposite angles being congruent? What do you say? Oh, BDH, is that what you're saying? BDH, this one, is congruent to A. That is true. Angle BDH is congruent to angle A because opposite sides of a parallelogram, right? What now? BDH. Can you use which? You can use the transitive. That's exactly right. Yep. Because they're congruent to the same one. Yep. It is transitive this time. It's your favorite. It's congruent to angle G because transitive property. We did it. That's pretty easy peasy. Not too bad. What about the other couple of proofs? Is there one of those we want to look at? Sure. "26 is one of those where it's wanting you to prove one of the theorems that it gives you in the book, right? So you can't use that theorem to prove it. So we are given that this is a parallelogram, right? G. K. Chesterton. L. M. All we are given is that it is a parallelogram. Oh. I made a mistake. Good enough. And we want to prove that angle G and angle M and angle G and K and angle K and L, all the, you can read it in the book. All the same side things, right? Are supplementary. Okay, so we only have a parallelogram. So let's think through all the things we know about a parallelogram, right? With the exception of one, because we can't use the fact that ones on the same side are supplementary. Consecutive ones are supplementary. Can't do that, because we're trying to prove that. What else do we know about parallelograms? We already said two of the things, so what were they? Opposite sides are congruent, true enough. What else? Opposite angles are congruent. This one is congruent to this one, and this one is congruent to this one. There's one more thing that we didn't say that is going to be important. It's part of the definition of a parallelogram. What did we not say? It's in the title of the shape, by the way. Yeah, parallelness. Opposite sides are parallel, true enough. Which is great, right? Because the fact that we know that opposite sides are parallel, we've got these lines that we can extend out so we can see what the heck is happening. We've got all these parallel lines and transversals and all that stuff, because we know a lot about that. We know that same side things are supplementary. Same side of transversal are supplementary. We know that alternate interior and exterior are congruent. Luckily for us, we're trying to prove that things are supplementary. So before we can start saying that, we need to say what I just said, right? We got to say that the lines are parallel, right? And then, yeah, exactly. Then we use that. So we got to say that GK is parallel to ML and GM is parallel to KL, because definition of a parallelogram. I don't know why I wrote it that way this time when I usually write it this way. I don't know, whatever. So then we can just say proof stuff, all that whole list. Just list from the book. Because same side interior. Done. Easy money. Easiest proof we've done in like forever. Like maybe ever. If we remember the tools that we picked up before. Let's look at 25 if we have time. I know that's not one that we assigned, but it's a little bit crazier and it's got some fun bits in it. It's not that hard. We pull in other chapters worth of stuff. So we've got a crazier shape with a couple of parallelograms intersecting each other. That's a straight line. I'm struggling. It's nothing like the book. You may want to look at the picture in the book to understand what has happened. It's on page 408. We are given that WXTV and ZYVT are parallelogram. We're supposed to prove that WX is congruent to ZY. So we only have, actually that's not really true. I was gonna say we only have two shapes. This is ugly enough that I'm gonna give it another try. I got this. You have faith in me, Gavin?
I do.
Yeah, that's a very bold choice. That's better. Still not perfect, but maybe we can see what the heck is happening now. X, Y, Z, T, V. So let me pause for a second, because this kind of thought process, this is probably good advice. Maybe I'll incorporate it at the beginning of the year next year. Sometimes I have brilliant ideas in the middle of class, unfortunately. Let's think about what shapes we have and what we know about them and what boxes we need to open in our head to solve this problem. So what shapes do we have? We do have a couple of triangles. We have triangles. And obviously we have parallelograms. I won't make you repeat all the same things that we keep coming up with because I think we probably got it by now. Opposite sides of parallelograms are congruent. Opposite angles are congruent. Sides are parallel, so we've got access to all the parallel line things. We may want to jot those down as well, right? Triangles. When we're proving triangles, we may want to get congruent triangles. So what are the 4 ways you can prove that a triangle is congruent? What is one of the ways? Starts with S. Or what? Nope, not that S. That does start with an S. Good job. How about side, side, side as one of them, right? What's another way we can prove a triangle is congruent? SAS, side angle side. True enough. What's another way? What? No, that's the only one that isn't. 2 S's and an A. There's no S in math. Yeah, but that's supposed to help you remember. So what are the other ways we can combine the letters that isn't that one? ASA. ASA. Angle, side, angle. True enough. One more way you could combine those letters. Angle, angle, side. What else do we know about triangles? We know that if you already have them congruent, you have this triangle is congruent to that triangle, what can we do with that information after that? What is the C acronym? No, the C one. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So if we can get a couple of triangles congruent, then we can say something about their sides, right? These are things. Now, because we're gathering up all our tools, it's parallelogram. It means the opposite sides are congruent. What theorems do we have with parallel lines? What are those tools that we have access to? What do we know about corresponding angles? Also, what are they? What? There's the transversal cutting through the parallel lines, true enough. I labeled those 1, 2, 3, 4, 5, 6, 7, 8, right? Which ones are congruent to which ones? 1 is congruent to 3. That's true. They're vertical angles. That's true. Where else is congruent? What else is number 1 congruent to? There's 2 of them. 8. That's true. 1 is congruent to 8. Because what are those called? I already said it a minute ago. Use the cheat sheet in your brain, not the one in front of you. What are 1 and 8 called? Corresponding. They're the only ones that are not as descriptive, right? Where else is another pair of corresponding angles? 7 and 4. It is a 4. He was uglier. I fixed him a little bit. I cleaned him up a little. 7 and 4, absolutely. 2 and 5, 6 and 3. All right? What else is number 1 congruent to? 6. What are those called? They are exterior. Are they same side or alternate? Alternate exterior, that's true. So we've got the alternate exterior, we've got the alternate interior, we've got same side exterior, same side interior. This is what, when you're hitting a proof, this is what your brain needs to be doing. It needs to be saying, okay, I need to open this box, I need to open this box, and I need to open this box. These are the ones that might have tools that I need, right? When I go and work underneath the sink, I don't go and open the woodworking box. I don't pull out my table saw to fix the plumbing under the sink. I go to the plumbing box and open it, right? That's what we're doing. Does this make sense? So, back to here. We're given, all we are told is that this is a parallelogram and that's a parallelogram. We're trying to prove, put that in a little box so we know that this is what we're talking about. We're trying to prove that WX is congruent to WY. So let's label with a different color what we're trying to prove. We're trying to prove that this, with a question mark, is congruent to ZY. This. Okay, so we're interested in sides, so we might be using opposite sides of a parallelogram, right? That might be useful. We've also got triangles. We may be trying to prove that a couple triangles are congruent. What can we do? What can we say? We just talked through a bunch of stuff we can say, right? We can start saying random crap until it like starts to appear. It's like when you build a 1,000 piece puzzle. You look and say, oh, this one's purple and this one's purple. Oh, they fit together. And then all of a sudden, the purple slowly turns into grimace, right? And then you get the Hamburglar over here, but then you say, oh, these all fit together because of this. Sometimes you do that with a proof. You're like, okay, well, this works. I don't know why I'm doing it, but maybe it'll help me later, right? So what is something we could say? Crickets. What can we say from this box? What does this box tell us? Because this is all we know is parallelogram, right? B and C. What? Yeah, so we can't call V, V, and we can't call X, X, but I think that you're correct. So which ones are you actually talking about? WVT and TXV? No, not that one, because that's this little one. It's got to be the big one, because this is the parallelogram. Yeah, of course. It said TXW. Oh, okay. Well, I can't hear you. Get the mush out of your mouth. Okay, so let's go ahead and get all the opposite sides in a list, right? That way we can go ahead and get that out of the way. Then we have access to all of that. So angle W is congruent to angle XTV. That's not the one you said, that's the other side. But then the one you said is also true. This one and that one, right? I didn't even mean to accidentally do the other one, but I did. WXT is congruent to angle, so WXT, that's that one up there, is congruent to angle WVT, right? So that's the ones in this little shorty parallelogram, right? This is congruent to this, and this one is congruent to that one. Hey, we may as well go ahead and get the big one on there as well. We've already got a couple sides of a triangle, so we've already got an A. We can get a couple sides or something, and then we could get one of these. That could be helpful. Let's keep on going. What are the opposite angles in the big triangle? I mean, big parallelogram. That's the word I'm trying to say. VTZ, yep. So angle VTZ is this one. What is it congruent to? It is. That one's all by itself, so you're right. You're saying it completely right. That one we can even just say angle Y because it's the only one there. But you're 100% right, and if you wrote that, you'd be 100% right. Absolutely. I'm just going to write Y to save our time. Okay, so what is the other ones? Y what? YZT. It's just Z, so it's by itself, so we'll just do Z. But you're right. That's exactly where it is. Y, Z, T is this one. What, and it's congruent to which one? The YVT. YVT. I thought we had two that matched, but we don't. They don't actually fully share any of those. Sad. That's okay. Okay. So this one is congruent to this one, and this one is congruent to that one. Great. We use this box. Can we say anything else about the two triangles? Do they share anything? Do they have anything else that's congruent? They share vertex V. Do they share an entire side? B, no, the triangles, not the parallelograms. This guy and that guy, do they share any sides? Vx. They share that, which is going to give us an S for this. That might be useful. Oh, this is opposite angles parallelogram, right? XV is congruent to XV. What is the reason for that when something's congruent to itself? Reflexive property. Mm-hmm. True enough. So we've got this. So we've got side angle or angle side. Actually, we don't even have that because it's opposite it. So we need another angle or something. We can say that VT is congruent to WX. We can say VT is congruent to YZ because those are opposites, and that gives us some things that we're interested in, right? So we may as well go ahead and put that in there. So this side is opposite that one, and this side is opposite that one. This is also in one of the triangles. So YZ is congruent to VT, and WX is congruent to VT because opposite sides. Of a parallelogram, right? We can, yeah. I was thinking that you might. We can go ahead and say that right now. May as well. That WX is congruent to YT because of the transitive property. No. Wait. Why do we do all that extra work? Is that literally what we're trying to prove? WX is congruent to VT. YZ is congruent to VT. WX is congruent to YZ because of the transitive property, which is what we're trying to prove. WX is Drew it to zy. Why did they go through all these steps of doing triangles? Oh, I'm looking at 23.
Well, we just said all things that are true. Good for us. Transitive property, we're done.
I said 25, and then I looked, oh, 25 is the flag one. Now we don't have time to do the fun flag one with triangles. That's okay. We did an easy one. We didn't have to say any of this. All we had to do was say, we didn't even have to say this. All we had to do was say this, and then transitive property, and peace we out. Good job for us. Okay, kids, I think it's time to go. Yeah, it's definitely time to go. I will see y'all on a Tuesday.